Well, students, in the last lecture, we have introduced futures and we have also understood its basic mechanism, that is the marking to market. In this lecture, we will try to understand how to obtain the fair future price. We denote the future price at any time t by f of t and its expiration is capital T. Okay. The time at which a contract is initiated is always taken as t equal to 0. Hence, a future contract from the time it is initiated till the expiry is the period of the future and it is an interval 0 to t. So the future price is in general different from the spot price of the underlying asset. And in fact, as I told in the last class, as time t tends to capital T, the future price f of t comma capital T tends to the spot price s of t. So our formula for pricing this term, that is getting a formula for f of t comma t, should basically reflect this property. Recall that the same property also holds for forward, and hence there is a natural question: is there a relation between a future price and a forward price? In fact, the theorem that we are going to state now is actually going to establish this relationship. It tells you something more stronger. The theorem says that if the prevailing interest rate is assumed to be constant throughout the future period, that is during this interval, the interest rate is assumed to be constant, then we will have the future price is same as the forward price. That is the theorem. Now, from the last section, we know how to obtain a forward price. That is, we have established a formula for forward price. So, under this assumption, in fact, the same formula can be adopted for even the future price. That is what the theorem says. Let us state the theorem first. Let us first write the hypothesis for the theorem. The first hypothesis says that the market allows long and short trades with fractional units. It means you can buy, say, half a share of a stock, or you can short half a share of a stock, and so on. See, this is just a theoretical assumption. Second is the market doesn't allow arbitrage. So these are the two hypotheses. Under this, if our prevailing interest rate is kept constant for the entire period 0 to capital T, where capital T is the expiration, then the theorem says that the price of the future at any time T is equal to the same equivalent forward price. That is, the underlying asset of the forward is also same and the period is also same. Okay, so that is the theorem. So we have to prove this. The idea of the proof is to establish two strategies, strategy 1 and strategy 2. Strategy 1 is based on a forward contract and strategy 2 is based on a future contract. So the strategies are built in such a way that the resulting portfolio has the same final value. That is, say we have a portfolio P1 here and a portfolio P2 here you have constructed, then the value of the portfolio at time T and similarly the value of the portfolio at time T here, they both are equal. Okay, so you have to construct the portfolio like this. You have to also construct it in such a way that the portfolio value of the one constructed using forward contract at 0 is precisely coming from this part, and the value of the portfolio initially, that is the initial cost spent in building the portfolio. Okay, so if this happens, then you can use an arbitrage argument to show that this implies these two are equal. Okay, now this will come from the price of the forward discounted, say, continuous compounding way, and similarly this is coming from the future because you built it based on future contract. Okay, future price. discounted with a continuous compounding. Similarly, you can also make a discrete compounding form, but mostly we will use continuous compounding. Okay, if these two happens, then you have these two equal. Okay, so this you have to establish using a arbitrage argument. Once you make this, then you will get this, and that will prove your theorem. That is the idea. So again, I will repeat. You have to build two portfolios, Pi 1 and Pi 2, one based on the forward contract and another is based on the future contract, in such a way that their initial value, that is the money initially spent to build the portfolio, is something like this for the forward and like this for the future. And in such a way, you have to build these portfolios in such a way that the final value coincides. This should coincide. Okay, then you can use arbitrage opportunity argument to show that if the final value coincides, then the initial value also coincides. Thereby, these two will be equal. That is how you will do. So the first part is to construct portfolios, and second is to show that if final values coincide, then the initial values also coincide. This probably you can do because you can just assume that the initial value is less than and then make arbitrage. Similarly, you make the initial value greater and then make another arbitrage portfolio. So this I will leave it as an exercise to you, but I will construct the portfolios, two portfolios, in such a way that their final values are equal and their initial values are separately this for forward portfolio and this for the future portfolio. So this part I will, construction part I will make and show you. And this I will leave it as an exercise. Okay, so let us go into the construction of the two portfolios. Let us start with the strategy 1, which is based on a forward contract. First step is take a long forward position with price f of 0, t. Remember, since forward is a non-contingent claim, it comes with no cost. So in order to bring in this long position into your portfolio, you are not going to spend any money on it at the time t equal to 0, right? What is, again, I'll repeat, what is mean by long forward position? It means there is an underlying asset and you are going to a forward market and buying a contract in which you say that you will buy 1 unit of that asset at the time capital T and at the price given by this value. That's a long position. That is the first part of your strategy. And the second part is, parallelly, you also invest this money, e power minus r capital T into f of 0, capital T, in a risk-free interest rate instrument. Say for instance, a bond. Okay, you invest this much money into a bond. Okay, our assumption that is that the bond is giving you interest rate of R for the period 0 to capital T, and the rate is not varying. So this is the strategy. Okay, this will give you a portfolio. Okay, you can write that portfolio. It has the B component as this, and S component is 0, and the forward derivative component as this, right? Okay, at time t, what you do? This is at time t equal to 0, and at time t is equal to capital T, you are going to close this portfolio. Or how the value of the portfolio will be, you can observe that it will have like this. You first close the risk-free investment. So when you close the risk-free investment, how much money you will get? You look at this. This is the initial investment you made, right? And it is continuously compounding with a amplification factor e to the power of RT, right? E to the power of RT is the amplification factor. Therefore, e to the power of RT and e to the power of minus RT gets cancelled, and you will get back the amount f of 0, capital T. That is the amount you will get back from the risk-free investment. And now what you do is you have a long position in the forward, that also you close. Of course, you have to close it because that's capital T is the expiration time. Close the long forward position. So how will you do that? You will buy this asset, right? Underlying asset. What is the price that you will pay to buy that asset? Well, it is the forward price that is quoted in your contract, that is f of 0 comma capital T. So at time capital T, we are taking these two steps, and thereby there is a difference happening in the portfolio pi 1, right? What is the difference in the portfolio? Your risk-free asset went off from the portfolio and you got 1 unit of the asset from your forward contract. Thereby, your portfolio pi 1 at time capital T is changed to your risk-free asset went off, and similarly your forward also went off, and you got 1 unit of your underlying asset, which is a risky asset. That's why you are doing a forward, right? So therefore you got a risky asset into your portfolio. And what is the value of this portfolio at time T? V of pi at the time capital T is nothing but the spot price of this asset. What is the spot price of this asset? Generally, we denote it by S of T. Okay, so that is the one part of your proof. And let us now go to construct a portfolio using strategy 2. This is based on the future contract. So for the sake of simplicity, we will consider only two intermediate time steps. 0 less than T1 is less than T2 is less than capital T. Okay. So this is just for the sake of convenience in applying the marking to market strategy. Once you understand two steps, then any number of steps is just a repetition of that. That is why we are only considering two steps. Let us get into this strategy. At time T is equal to 0, we build the portfolio like this. That is at the initial level. Take a long future position with the on e to the power of minus or T minus T1 unit of the underlying asset. So this is just one fraction of that asset. We have assumed that such trades are possible. And then the next strategy is to invest an amount of e to the power of minus r capital T into f of 0 comma capital T. See, when you are taking this on the underlying asset, at future price is f of 0 comma capital T, and it comes with no cost, right? Because future is also a non-contingent claim, therefore there is no cost involved in it. So invest an amount e power minus RT into whatever you settled with in the forward price. That amount, you invest that much amount in the risk-free asset. So it's an interest rate asset, therefore it gives you an amount of f of 0 comma T at the time capital T, because it amplifies with a factor of e power RT. So we have built the portfolio like this. Okay, so let's call this as P2. At time T equal to T1, what will happen? You will receive an amount of, or you may also pay instead of receiving. What is the amount? The amount is, see, you have taken only this much unit. You did not take one full unit. Therefore, your marking to market will give you how much? It is f of T1 comma capital T minus f of 0 comma capital T. Why it is like this? Because you are taking a long position in the future. Therefore, your marking to market will give you this money. Otherwise, it's the minus of this. And since you have made the contract only for this fraction, okay, therefore you get this much money as a result of the marking to market. Okay, of course, this will not change your portfolio position. Therefore, your portfolio is still pi 2 only. And then what happens? Let us see. You got this money, or it is taken away from your margin deposit. One of these would have happened depending on whether it is a positive or negative. So you either invest, in case if that was positive, then you got that money, so you invest it in the risk-free asset. If you would have lost this money because it was a negative, then you borrow depending on the sign of this term. Okay, you invest or borrow this much money, e power minus r into t minus t1 f of t1 comma capital T minus f of 0 comma capital T in the same risk-free asset that you have invested here. So how much it will give? This will give, say V1 at time T1, it is V1 is equal to how much it gives you? This much money, right? Because this money is discounted with this factor. Therefore, when you go forward in value, it is amplified by this factor. Therefore, you have f of t comma capital T minus f of 0 comma capital T, right? So this is the amount it gives. Similarly here, how much money you will get? This gives V naught is equal to f of 0 comma capital T at time t is equal to capital T. Okay, similarly here at time t equal to capital T, you will get this much money. Now what you do is you increase your long position in the future to e to the power of minus r into capital T minus T2. That is the next time step. Again, this will come with no cost, right? Now let us see what will happen to this portfolio. Let us denote this portfolio by pi 2, and it is constructed at the time t1. Okay, at time t2, what happens? You will receive or pay depending on how your future price went between t1 and t2, the amount of e to the power of minus r into capital T minus, previously it was t1, now we have increased our position to the unit e power minus r t minus t2, okay, times f of T2 comma capital T minus f of T1 comma capital T. You should recall the marking to market process. As per that, if you hold 1 unit, you will get this much money, but you are having only a fraction of 1 unit, that is the fraction is this much. Therefore, the amount that you will receive from marking to market into your margin deposit is this much. Now, depending on whether you received or paid, you invest or borrow this much money, e power minus r into t minus t2 into this in the risk-free interest rate asset. It means the bond that you have been investing in the previous time steps, in the same bond you may invest again. And again, you recall that this gives how much money at time t equal to capital T? It gives you this much, right? F of T2 comma capital T minus f of T1 comma capital T. It will give you at time t is equal to capital T, not today. That is not at time t equal to T2, but it will give at t equal to capital T. Okay. Since we have considered only 2 time steps, the next time step for us is capital T. Therefore, at this time step, if there is an intermediate time steps, again you have to invest the forward long position in fractions only. Now, since you are the next time step that you are going to consider is capital T, you increase your long forward position to 1 unit. Again, it involves no cost. Okay, let's denote this portfolio by pi 2 happened at time t2. Now finally, at time t equal to capital T, what happens? If there are more time steps, intermediate time steps are there, then you have to do this process again and again till capital T. Okay, since I have taken only 2 time steps, therefore the third one I am touching the expiration. So at time t equal to capital T, how much we are going to receive from the risk-free investment? Let us see that first. Say at initial time t equal to 0, what we invested is giving us V naught. Okay, that was actually f of 0 comma capital T, because we have invested e to the power of minus r capital T into f of 0 comma capital T. Therefore, at t equal to capital T, we get this. This is at time t equal to 0. At time t is equal to t1, we got v1. Right, t equal to t1. How much we invested? We invested whatever we obtained from the marking to market, and that is amplified, right? So that is going to be t1 comma capital T minus f of 0 comma capital T times e to the power of minus r into capital T minus t1 we invested. That at time capital T has become like this. Okay, and at time t equal to t2, what we have invested is going to give us v2, and that is going to be f of t2 comma capital T minus f of t1 comma capital T. So this is coming from our second term marking to market amplified. Okay, so this is what we are going to get from the risk-free investment, and that is, you can see this gets cancelled and this gets cancelled, and you have f of t2 comma capital T. So this is what we get from the risk-free investment, and when you close the future, what we get is the final marking to market payment. Remember, at the final time, we are holding one full unit. Therefore, the marking to market at the final time is going to be the present value of the future price minus the previous future price, that is at t equal to t2. Okay, but you know this is s of t, right? So you have s of t minus f of t2 comma capital. So your portfolio at t equal to capital T is going to close this and also close this future, right? It basically will not have anything in its portfolio. Therefore, the value is going to be, that is the wealth that you obtain out of all these portfolios is going to be the sum of these two values. That is, from the risk free you are getting this, and from future you got this. So its sum is actually s of, this is say at capital T. Recall, from our strategy 1 we got v of pi 1 at capital T was s of t, and from strategy 2 we got v of pi 2 at capital T is also s of t. So they both are equal. This is what we have initially aimed at, and we achieved a portfolio, two strategies that give the same final value. Okay, and by arbitrage argument, we can show that the value of these portfolios at the starting point is equal to the value of the other one. Okay, remember initially how much we put? We put e power minus rt into f of 0 comma capital T is what we have put in the forward strategy, and in the future strategy we have put e to the power of minus rt into f of 0 comma capital T. How? Let us recall. In forward strategy, what we did? In the forward strategy, there was no cost involved in the first step, but the second step we have invested in risk-free asset, and that amount is this. That was the initial cost that we paid to build the portfolio pi 1. Therefore, this is what is the initial cost of pi 1, e power minus rt into f of 0 comma capital T. And how much we invested initially at the second strategy, that is the strategy based on future. Let us recall. At time t equal to 0 in pi 2, the first step had no cost, and the second step we have invested in the risk-free asset this much money, right? So that is the cost involved. So that is what I have written here. So that implies f of 0 comma capital T is equal to f of 0 comma capital T. See, this to this I'm not showing, but you can prove it by taking this is less than this, then you again construct another portfolio strategy that gives you an arbitrage, and then again assume that this is greater than this is greater than this, and again you construct one more portfolio which is again leading to an arbitrage. Therefore, since the market is assumed to be no arbitrage, these two cases are not possible. That is, the inequalities doesn't hold, therefore equality holds. That's how you have to conclude. I think this we have done in the forward pricing model. The very first theorem we have proved it. The same idea goes everywhere. Okay, that's why I'm not doing it. So you finally got the conclusion of the theorem, and I think this completes the proof of the theorem also. What this theorem says is, in fact, this theorem gives us the pricing model for future also. If you recall, the pricing model for forward was given by S of 0 into e to the power of RT. Okay. In general, if you have f of t comma capital T, you have S of t e to the power of r into capital T minus t. Okay. So this can be now made for any time small t in the interval 0 to capital T. Therefore, the same idea can be adopted to make this formula, and now that is equal to f of t comma t. In case if there is no extra cost involved in the underlying asset, as well as no dividend is paid by the underlying asset, then this is the model. Otherwise, you have corresponding models. You can adopt them, one of them, as per the situation. I'm just writing here when there is no cost or no dividend involved, then forward is given like this, and therefore, thanks to our theorem, the future is also given like this, provided, remember, your interest rate is kept constant, because at every time step, we are investing systematically into the risk-free or borrowing from risk-free asset, right? Therefore, all these interest rates are actually equal. That is why we are doing like that. Okay, and also you should remember, in all these steps, we have assumed also that the borrowing and the lending rates are same. That is also an assumption we made. So you have to carefully remember the assumptions so that you know what are all the limitations of these models. So although the interest rate in general is not constant, in reality, this model is quite efficient in predicting the price for some routine analysis. Okay, therefore, this is still not a bad model. It's pretty acceptable model in that sense. You can observe that when the future price depart from this value, okay, so when does the future price becomes different from what this model suggests is one reason is when people predict that the interest rate is going to be different, then they plug in that interest rate and then work with this formula. Therefore, your this model with a constant interest rate will differ in the reality when people predict either more or less in the interest rate, then they plug in that interest rate which they predict and try to use this formula. In that way, they will get a different price. So these are some of the important remarks that one has to keep in mind when we are using this model into real life.